Hi guys, and welcome to this video on, well, indices, and it's the start of our indices and surge section for this chapter. My name's Darren, thank you very much for joining me. If you can, please subscribe to my YouTube channel. Oh, I've only got about 3 subscribers, and just knowing that people are watching is greatly appreciated. Now, what's this video going to deal with? As you can see here, understand why we use indices, which I'm going to call floaty numbers, because they are numbers what float. How to explain base and index, and write something in expanded form, and evaluate powers and all those things that you can see behind me. Now, if you have any questions at any point in this video, put them in the comment below. If you're watching it on YouTube, if you're watching it on mathsguru.com and you have subscribed, you can send me emails and I'll answer your questions. Okay, so in previous parts of this course, we've learned about BIDMAS. You've been knowing about this for years, and it's brackets and indices and division. What do you mean use BIDMAS? What do you mean use PEDMAS? What do you mean use BODMAS? No, it is BIDMAS. Let us not argue about this. That is not, it is fine. It is BIDMAS. Why? Because the I stands for indices. As we say here, indices, another one of those stupid things that we actually talk about in maths all the time, I think of them as floaty numbers. They are numbers what float. Now, before we get into the exciting stuff, let's start gently through this particular part of the course. And as I say here, Barry has been at it again. Oh my God, Barry, will we stop it? He literally thinks that the whole point of maths is to make it hard. So should we give, maths teachers stand there in front of the classroom and we spout out all this stuff and you're like, my head is spinning, what on earth is going on? Because, Barry's told us to make it hard. Well, I'm sorry, I'm not going to. Barry, you can go do one. I'm actually going to do this myself. So, first things first, indices has so many different names as well, all right? So we can call it an index, we can call it a floaty number, that's mine. We call it an exponent, we call it a power. Doesn't matter what we call it, the point of it is the same, all right? It is a floaty number. It means something, and we'll explain what that means in just a moment. But wherever you see the word exponent or power or index, it means exactly the same thing. So let's go to expanded form, all right? An expanded form, as I say here, simply means you take a base. It's all about the base, No, I'm not Meghan Trainor really, am I? No. Okay, so it's all about the base and an exponent or the index form. So the first thing first, let's work out what a base is and work out what an exponent is. This thing here is the base, all right? So that big letter is going to be, from now on, the base. And anything that floats that's connected to it is called our index. Now that does not mean x times 4 or 4x, it means something quite different. All right, so that is where expanded form comes in. X to the power of 4 basically means x times x times x times x. Now, do you notice here that I've written my x and my times sign very, very differently? When we do algebra, my advice to you guys is always write your x's as a backward C and a forward C. Because that makes it very different then, that when we look at this, that it doesn't look like, otherwise I'm going to get x times, it just looks like I'm just doing a load of kisses. And I love you, but not that much, because that's weird. All right, so we don't like to do all the x's in the same thing. I know that some people do their x's like that. From what I understand from examiners, particularly at year 11 and 12, they really don't like that as a value of x. And in fact, I think I was told by an examiner once that they won't mark any questions that has an x like that. So my advice to you is always do your x like that. Now that's expanded form. Literally, that floaty number, where has it gone? That floaty number there, that floaty 4, tells you to write the base that many times with a times in between it. So it is the same as x times x times x times x. What about if we had x cubed then? All right, x cubed, that is a floaty 3. It's not very floaty, but it is floaty. That's the same as x times x times x. Oh, okay, so x to the floaty 10 would be way too many x's for me to write in this particular video. But you see the point now? X times x times x times x times x times x, and so it would go on. Now, obviously, they then try and trick you, because maths is a big fat trick. And when we have x, y, to the floaty 4. Now what that basically means is the brackets tell you to treat that like one thing. And the floaty number tells you how many times to write it. So I now know I'm going to write the x, y 4 times. What am I going to put between each of those x, y's? Absolutely a kissy kissy. Oh, now if you haven't watched my other videos, you'll have no idea what I'm talking about. And I think of a kissy kissy as a times whole new story. Go back to my algebra introduction. You'll love it. Right, so what do we have there? We would have xy, that's once, times xy, that's twice, times xy, that's 3 times xy, that's 4 times. So the trick to this is the floaty number tells you how many times to write what it's connected to by, and then put times in between them, yeah? So the floaty 4, write the x's 1, 2, 3, 4 times, and then put kisses or time signs between them. Easy, really? Now, one of those other trick words that comes up in maths all the time is evaluate. Now, I'm not actually speaking to you slowly for a reason, but again, maths does try and help you. Barry has those tricky moments where he does turn around and say, I'll go on and give man. Evaluate. And the point of it is there, when you have evaluate, it is asking you to find the value. So it wants some specific numerical value that it can work out for you. So again, if we look at this one here, what have we got here? 5 to the power of floaty 3. So that would be 5 times 5 times 5. Now we've written it in an expanded form, but we haven't evaluated because in that particular instance, we can work out what 5 times 5 times 5 is. Now when I do these, I do tend to do them in pairs. 5 times 5 is 25. I copy down the 5. 5 times 25 is 125. And there we go. I have now evaluated it. 5 to the floaty 3 is 125. What about minus 2 to the floaty 5? Now, one of the things to notice here is the brackets. Why on earth do you think we've put those brackets in? You already know this. Because it is trying to make you see that minus sign. That minus sign is a tricky one because your brain, funny enough, is pre-programmed to ignore it, to forget it. And the brackets help us go, oh, I can see a minus sign. All right, so it goes along, you start reading, you see the brackets and you go, oh, I see a minus sign. It's almost like a trip. It allows your brain to trip and see that minus sign. And how does that help us now? Well, what it tells us is, remember the floaty 5 says write the minus 2 5 times with minus signs in between it. And you're going to say, wow, this seems so long. And I'm like, yeah, sort of. But the point of it is, it's actually important. Now, how am I going to do this now? Because I want to evaluate it. So we've got minus 2 times minus 2 is 4. Remember, 2 times 2 is 4. Minus and a minus becomes a plus. What about this one here? 2 times 2 there becomes 4. Now, I haven't currently used that times sign, so I'm going to copy it down. And I haven't done that one at the moment, so let's times that by minus 2 and copy it down. Well, do you notice I'm doing it in pairs? Makes my life easier. Another pair. 4 times 4 is 16 times minus 2, and then hopefully 16 times 2 is 32, and a positive and negative gives me a negative. And there we go. So minus 2 to the power of floaty 5 is minus 32. Now it's funny because most times when I put the word fractions at the top, people go, no, I'm stopping this video now, I'm done, I'm not watching this anymore. And why? Fractions are fabulous. Okay, I've done fractions videos as well. Hopefully I can break those down for you as well. But one of the easiest things for fractions is multiplying them. We love multiplying fractions because you just multiply the tops and you multiply the bottoms. Job done. So can we now use floaty numbers with fractions? Well, of course we can. Because what have we got here? We've got 2 fifths to the floaty 3. And again, what does the floaty 3 tell you to do? Write that down 3 times with times is. So that becomes 2 fifths times 2 fifths times 2 fifths. What do we do now? Oh, we like timesing fractions because you just times the tops together and you times the bottoms together. So I'm going to do that. I'm going to do 2 times 2 times 2. 2, 4, 8. So there's 8 on the top. And then I'm going to do 5 times 5 times 5 on the bottom. Now, if you want to, do 5 5s are 25, times that by 5, 125. You can actually do side calculations, that's fine. And that becomes 8 on 125. Now, you would need to check there that you could cancel that down or that it is in its simplest form. And I already know it's in its simplest form because if I could cancel down, I'd already be able to do it with some form of the fractions at the start. Yeah, now if you're looking at a video for cross-cancelling, that's coming later as well. All right, all these tips and tricks, but we're just dealing with the basics for floaty numbers at this moment in time. Now we need to realize in maths, so what we do forwards, we can also do backwards. If we can write something from index form into expanded form, we can go from expanded form into index form. Yeah, so when you see a number or a letter that is repeated with a set of times signs in between, we can reverse the process. Because to be honest with you, in this situation here, no one is going to want to write that out, are they? That is long. So being mathematicians and being lazy, we want to try and find out how to write this quickly. Right, okay, so what have we got there? We've got 6 times x times x times x times x times x. Well, they're all multiplied together. So the first thing I'm going to do is say, do I have more than one 6? So that's going to stay 6 there. But I got those letter X's, they're all repeated and they've all got time signs in between them. So how many X's have I got? 1, 2, 3, 4, 5. So I can now write that as times X to the power of floaty 5. That's much easier to write. And you're going to turn around and say, well, do I need that extra times in between? Nope. So actually, I can write that down as 6x to the floaty 5. So I've just taken something from expanded form, right? Remember again, that there is expanded form into index form or index notation. Oh, here we go again, Barry. Index form, index notation, same. Again, let's do some now with fractions. This isn't tricky, we can do this. So what do we see here? We're trying to find, firstly, answer yourself the question, are they all multiplied together? Because this only works if all of the individual things are multiplied together. And for this first example here, let's put the number 1 there, they are all multiplied together. But what do we notice? We notice that those 2 are the same and those 3 are the same. And so they're trying to trick me. Doesn't matter though, because the first thing I'm going to do is say, well, let's write one of the things first. So we got the brackets and 3/7, because that's written twice. There's a times in between them, so that becomes a floaty 2. And we're going to do times, and we got 4/5 to the power of 3. And believe it or not, guys, that is my right answer. Now, you could miss out that middle time sign. I think leaving it in just makes it look that little bit easier to read. It's no different from taking it out. It just makes it easier to read. What do we notice here? Oh, they're trying to trick us. Remember, when things are all multiplied together, we can change the order. All right, we can put all the numbers together. We can put all the like letters together. And so here, how many 8, are they all multiplied together? That's the first question. Yes, they are. So what are we going to do now? We've got how many 8s? We've got 2 8s, so I'm going to write that as 8 times 8. How many A's have I got? 1, 2, 3, so I'm going to write that as A times A times A. And how many B's have I got? I've got 3 of those as well. B times B times B. So again, they're all multiplied together, yes? Awesome. Do we have any repeated letters or numbers? We do. So this here, that 8 times 8 can be written as 8 with a floaty 2. We could write it like that. In fact, let's write it like that, yeah, because it wanted in index form. What about this one there? A times A times A. So that's A with a floaty 3. And we've got B times B times B. So we've got to do times B with a floaty 3. And there we go. Now, generally speaking, I think we would write 8 squared properly. We wouldn't necessarily write that in index form. So that would be 64 A cubed B cubed, ka-ching, and there we go. And in this situation, we would take out these time signs here, simply because it doesn't add anything to the question. It doesn't help us to leave them in. We can actually write it a little bit more compressed. Now, one of the things we use this for is product of primes. Now, we remember a prime number is a number which only has 2 factors, right? And a product means times. Now, a wonderful way we can do this is using a factor tree. I love factor trees, they're great, they are. So here is an example. Express 48 as a product of its prime factors in index form. Brr. A lot of stuff in there, a lot of language that trips people out. But let's go first. Express 48 as a product of its prime factors. So what I do is I draw a number tree or a factor tree. So I'm writing my 48 at the top of my tree, and then I always write 2 lines. And I'm trying to say what 2 numbers multiply, i.e. product, to give me 48. And lots of people go, 4 times 12. And I'm like, yeah, but why would we start there? I always divide numbers by 2, and then 3, and then 5 to make it. I can always half numbers in my head. It makes life so much easier. So here, I'm going to split that up into 2 and 24. Now again, why? Because we know that 2 times 24 is equal to 48. So that's why I've chosen the 2 and the 24. Now, every time I hit a prime number, I put a circle around it, because I can't go any further with that. That 2 is just going to stay there. The reason being is if I have a 2 and split it up, I'm going to have 1 and 2, and split it up, I'm going to have 1 and 2, and split it up, I'm going to have 1 and 2. You're going to be going forever, all right? So that to me seems a little silly. So what I'm now going to do is I get to 24. What 2 numbers multiply to give 24? Well, let's start with 2. Does 2 go into 24? Yep. So 2 and 12. That's prime, put a circle around it. 12 could be split up into 2 and 6. See, it's so easy just halving the numbers. And 6 becomes 2 and 3, and they are both prime, and I can't go any further because they've all got circles. Right, have I finished? No, because now I have to write it as a product of its primes, which means I could write it as 2 times 2 times 2 times 2 times 3. Where did I get all those numbers from? 2 times 2 times 2 times 2 times 3. Now, if you want to check that, I promise you 2 times 2 times 2 times 2 times 3 is going to give me 48. Okay, now have I finished the question? No, because it says in index form. That's not index form, is it? Because we've got repeated numbers that we can use floating numbers for. So therefore, my correct answer would be that 48 could be written as 1, 2, 3, 4. We've got 2 to the power of 4 times 3. And again, we'd probably leave it like that. A lot of this is all convention and stuff you just get to learn. Because sadly, if I wrote 2 to the floaty 4 with the 3 there, that looks a little confusing. And some people's handwriting might make that look like 243. Not really helpful, is it? Now, the last sort of types of questions that we can have here, again, is where we now have to find the missing number. And thank you so much to Cambridge for allowing me to use their questions in my exercises. Cambridge textbooks are awesome. They really have got me through all of my teaching. Thank you very much to Cambridge. Right, what are we going to do? Find the missing number. 3 to a floaty number gives me 81. What floaty number could that be? Now again, you may not know what the answer is, but this is how I tend to do it. I actually say, well, this is my base number, and I've got to times it by itself a certain number of times to get to 81. So here we go, I'm going to do 3 times 3, and I do a line, and I say, well, that's 9. That's no use to me. Times it by 3, that's 27. Times it by 3 gives me 27, 7, 14, 21, 81. Now again, I'm doing this in my head, but there we go. So I've got to the number I want, 81. How many 3s do I have? 1, 2, 3, 4. So we now know 3 to the floaty 4 gives me 81. So in that situation, my missing number would be 4. Now the very last part of this goes back to a question we did earlier, really, didn't we? So if you remember, we had minus 2 to the floaty 5. And what we found out was that became minus 2 times minus 2 times minus 2 times minus 2 times minus 2. So let's write that out. Minus 2 times minus 2 times minus 2 times minus 2 times minus 2. Now actually, if we go back to our rules that we've had before, remember, if we have a positive and a positive, or a negative and a negative, they become a positive and a negative and a positive become negative, yeah? Okay. So what I'm now going to do is I'm just going to look at my numbers first. I'm just going to do 2 times 2 times 2 times 2 times 2. I'm going to leave all the minus signs for a moment. 2 times 2 is 2, 4, 8, 16, 32. All right, so that becomes 32. Now if we notice, we know that 2 minuses become a plus. So that minus there and that minus there, when they multiply by each other, become a plus. And that minus there and that minus there, when they multiply by each other, become a plus. And we would be left with that 1 minus sign there. Okay, so what about minus 2 to the floaty 4? Well, that would become minus 2 times minus 2 times minus 2 times minus 2, which gives me, well, 2, 4, 8, 16. So that's 16. That minus there and that minus there become a plus. That minus there and that minus there become a plus. And so that becomes plus 16. Now, if you continue doing this, what you'll notice is every negative number with an odd power always becomes negative. And every negative number with an even power always becomes positive. And that actually sort of shortcuts things. So if I had, for example, let's do minus 3 to the power of 3, that there is an odd number. I've got a minus sign, so I know my answer is going to become out as negative, and now I just need to do 3 times 3 times 3. Well, 3 3s are 9, 3 9s are 9, 18, 27, so that would become minus 27. And there we go, guys. That there is the end of my lesson. Thank you so much for watching. Hopefully it has been helpful. More videos coming on indices, on mathsguru.com, and possibly on YouTube. Please spread the word about my channel, and I look forward to seeing you again in another video. You take care, stay safe, and and I'll see you again soon. Bye-bye.